Let's try this. This will have to work. Right, welcome to my presentation on culture plates and how they differentiate between the bacteria. We've done some of this recently in the lab with the McConkey plates and the gram staining and stuff like that. And here we've got a diagram of up here there's gram positive, gram negative, there's differentiation between that. And then we can start to look at some of the specifics, which I'll talk about today, whether there's catalase positive or negative, hemolysis, so we can look at the horse blood, agar, lactose fermenters on McConkey plates, and the growth requirements. So the classifications, we can look at cellular structure, whether there's peptidog, peptidoglycan, metabolism, anaerobic or aerobic. Is it lactose intolerant? We just spoke about this, some of the fastidious growth requirements, antibiotic resistance, that sort of thing. So this is, you might say it's a bit of a dry topic, so I have decided to get Dali involved and threw it stuff like a surrealist dream, like oil painting of Dali of the words McConkey. That's what it came up with. So I'm going to do a bunch of those, and I've turned up the thing so it gets a bit crazier each time. So this will be interesting. Cellular morphology, first of all, so gram positive means that there's peptidoglycan in the bacterial cell wall. If it's gram negative, then it doesn't have that peptidoglycan that can be stained. So if we select for enteric, bacteria from the intestines and things like that, which are generally going to be anaerobic, don't require air to grow, we're going to use a McConkey agar plate, which is pictured here, or we can use a plate called eosin methylene blue, which selects also for gram negative bacteria, and also selects for lactose fermenters, which we spoke about earlier. So we've got a gram negative, and also we've specified that it's a lactose fermenter or an acid producer. Let's have a look. Oh, McConkey agar. That's pretty crazy. Oh my god. It's a blue screamy boy. The methylene blue plate. It's getting interesting. We can also look at metabolism. So I spoke about this earlier. We can select for catalase because it allows us to differentiate between a streptococcus or a staphylococcus, particularly when we're looking at Staph aureus, which is, or the methylene resistant, the MRSA. It's a clinically significant bacteria. We want to be able to put it on a plate and check for whether that's there. And you can't do that with catalase on its own. So we need a mannitol salt agar plate. This is what AI thinks it is. That's nice. Looks like Yoda. We can also do horse blood agar to check for whether there's hemolysis. So if we've got beta, which is here, that's complete hemolysis. Alpha's partial, it comes up as green. We had this in the lab the other day. And it cultivates bacteria which demand high nutrient levels for growth. Haemophilus influenza and Streptococcus pneumoniae are typical of these, so we can select for that. And then, oh my god, horse blood agar. This one's nice though. This one, I don't know. Let's continue. Let's continue. Fastidious eaters. We use chocolate agar for that, which is heated blood. It's rich in growth factors. And then there's a subvariant of that, which is the Thiamartin agar, which it contains antibiotics and a bunch of other stuff, which is basically allows us to select for this specific fastidious eater in terms of the Neisseria species, so gonorrhea, or more rarely the meningitis ones. Chocolate plate. That's cool. I would eat that. Incredible. Okay. We've also got non-standard presentations. We've spoken a lot about tuberculosis, including this week. And because there's no peptidog cell wall and peptidoglycan cell wall, we need to use a different stain. It's a non-standard stain. It's a Ziehl-Neelsen stain, which stains the acid-fast cell wall that this particular mycobacterium has. Oh my god. This is a mycobacterium lung, according to AI. It's getting crazier. And a bacteria driving a Lamborghini. Good. Told you it'd be interesting. All right, conclusion. This allows for identification of bacteria that can be achieved with microbiological techniques. So if we want to look for morphology, metabolism, like being an anaerobe or lactate metabolizer, also growth preferences, whether they're picky eaters, fastidious eaters, persnickety eaters, whatever you want to call them. We can isolate those different bacteria using these criteria and be able to culture and confirm what the organism is so that we can treat that organism. Let's just marvel in this again. Oh my God. See ya.